So when you think of design and AI, we can think of different steps of the design process, from identifying like needs, and then conceptualizing maybe a physical or a geometric solution, and then producing that solution or manufacturing it. I mean, these can all be considered parts of the design process. And where does a computational or a learning-based tool get inserted into each of these, or into all of them, horizontally integrated, and then extended throughout the life cycle of the product? That's all interesting.
Hello and welcome. The following is a conversation with Haluk Akay. He's received his PhD in mechanical engineering from MIT and is currently a postdoc at KTH, working with AI and design principles to utilize engineering knowledge in decision making in sustainable manufacturing. Our conversation spanned upon many different aspects of AI and their implications. We also discussed microelectronic mechanical systems, otherwise known as MEMS. It was a truly enjoyable and delightful conversation, and I'm deeply honored that he agreed to participate in the podcast. I hope that you enjoy the program. Could you give a slight introduction to what axiomatic design is?
Axiomatic design, yes. Yes, we can definitely start from there. I mean, maybe we can also back up a bit, I guess, and think of like design in general. I mean, so axiomatic design is a methodology, and it's one of many ways of performing design. And we're also, design is a big term. I mean, you're in computer science, right? And so when you think of designing a product or a algorithm, you probably have like a process of doing it. You don't, maybe you get inspiration from something and then you make a code and you have some inputs and outputs maybe. And if you're thinking about a product, that's also different. You think about like a user maybe in both cases. At some point you want to have something creative, right? Or else, what's going to be exciting about it? And this is a bit of a gray area, but when you think of like human creativity, it can get a bit disorganized, right? Like the line from problem to solution is like very circuitous, as you can imagine. And that's good because I think that's how we like find new things that are undiscovered before. But then when you think of design in like an educational or like a methodological framework, you want to bring some sort of order to this process. So that's you can say the entry point to a design methodology, of which there are many. So yeah, if you're talking about product design or systems design in the context of engineering, then you could think of axiomatic design. So axiomatic design is from the 1970s, which is an interesting time when a lot of computational tools are being introduced to the design process. And I guess from a historical perspective, it comes from MIT, and it was my PhD advisor's PhD advisor who invented this. So it was like very steeped into the kind of design culture in this group of research, and I guess the word axiomatic design comes from axioms, which are these kind of like truths you can say, or these. There's a definition for that, I think, in Greek or something. It's like some
basic truths, if
something, yeah, that doesn't require like a proof or something. And so there's two in axiomatic design, and it has to do with information, and maintaining functional independence is another one. But it's basically a way of guiding your complex problem solving in a way that you'll get like elegant and good design solutions in a repeatable way. So you can go along in very detail into the like mechanisms and the principles behind axiomatic design and what it means for a design to be well designed according to this methodology. But that's kind of a starting point, I guess.
And if we go a bit into
Yeah.
like what a good design is, I mean, I would say let's dig into it from a company's perspective. What modern companies do regard to be a good design?
Yeah, I mean, then you can think of which company, right? 'Cause
Let's
there's
go with a software company.
software company. Again, it's I mean, nearly every company is a software company these days, but I can like draw two different perspectives. So we can consider something like Apple versus SpaceX, you know. So both are software companies. You could argue both are hardware companies too, and both are design companies. Uh, but so different in the way that the products work, right? SpaceX is kind of focused on one product at a time, and the performance is just so key. It's such like a acute instance of testing for that. You know, the whole world actually is like watching as this product performs, and then you kind of only get one shot. Of course, it's a bit more than that. Apple, on the other hand, I mean, we have those products right here in the room. That's something that you're going to have to also, though, do very well and nearly perfectly, but on the order of hundreds of millions, right? So then what does design mean in those two cases? I mean, one's going to be a lot more focused on repeatability and manufacturability and keeping costs down. And then the other is going to be like achieving performance in a way that maybe has never been achieved before in unknown conditions once and do it well. So what is good design? Good design is, you can say, a satisfaction of the requirements that have been set. So they have different requirements. And if you can satisfy those, then, and this is where axiomatic design can come in as well. How do you satisfy these requirements? Like, where do you start from? And how does the solution to one requirement affect other requirements, for example? Maintenance of functional independence is one of those axioms. So that's just a bit of an example there.
And in terms of how we can effectivize the process of designing, now we will get into AI, but if we start before that, how far have we come along in like fine-tuning design processes without any AI usage? Of course, you know, it's always hard to say where AI starts from like algorithms to some sort of a more intelligent system.
Yeah. Like how good is design at its, at the state of the art? When you think of what is the best designs? I mean, that's also interesting. You can say also, what does it mean by before computational tools is, or AI, I mean, AI is a broad term. You can, I mean, in some ways, you did like engineering design almost peak in the late 1960s by putting a human on the moon, right? I mean, that's kind of a huge design feat, going again with like the space exploration theme. But then also today, you mean making millions of iPhones to the exact same level of precision and performance so repeatedly with all these different suppliers and working with different materials and so many different components. That's also pretty cool. I guess it depends on how you quantify like what is good design and how we reach there. But it's also time relative. I mean, you can look back to the steam engine, right, and then say that was really a huge design accomplishment compared to what we had for tens of thousands of years of human, industry before that, or civilization before that. Opened up a whole new world of technological possibilities. So yeah, so I mean, we can look back, 100 years from now and then say, okay, well, this was still pretty early. Real design hadn't, blossomed until maybe something that's going to come around the corner, soon. So hard to say.
It's interesting to think about, like, considering the computational power that's put the man on the first man, at least, on the moon. Yeah. And there's always these pictures of Grace Hopper's calculations and codings for the Apollo programs of just being like as tall as she was. Yeah. And considering how much computational power that we have right now. So it's interesting to see like how the progress has gone. Do you think we have become slightly maybe even sloppier to some degree? Because we have a bit of a more playroom for our design processes to...
Sloppier? How do you mean by sloppier?
Well, I feel like, at least in computer science, because we, in many cases at least, have so much computational power these days, many students don't consider writing the most effective algorithms at all times.
Sure.
Do you think that something slightly similar might have started to occur at least in design processes as well. Now that we just
Yeah,
started going
sure.
on.
I mean, that's when you have a resource constraint, right? And you have to innovate based on that constraint. Then you have to, I mean, you're limited in some ways, but you have to be that much more lean and perfect in some ways, right? Yeah, especially if you have a computer or computational source that only runs a certain amount of calculations, then you have to be careful with that budget. I mean, it's like a millionaire going to the grocery store, right? Like, or someone on a normal budget. You know, you have to be a bit more careful. Um, yeah, that's an interesting way to put it, especially for design. So there is work. There is a professor at MIT who was looking into the concept of reverse innovation. So this is basically, yeah, like you said, if we're in a very developed, sort of environment, and we have too many resources, is there something we can learn from still like low resource innovation, in, for example, countries in the global south or things like this, and going to those places, looking at the problems they're facing with their resources, trying to develop a solution, and seeing what kind of learnings come out of there, and then bring it back. Amos Winter is a professor working on that. And that's really a fantastic approach, because then not only, I mean, you solve these problems for these people, but you learn something in that you kind of simulate the resource constraint that you don't really have anymore in your own setting. So.
And now if we suddenly introduce the concept of AI
Sure.
in design, let's first go a bit through like what AI in design, when we talk about it, how we define it, and like give some borderlines on what we are talking about.
Sure. Yeah. Because AI is a big. Those are both AI and design are very large terms. And so yeah. So when you think of design and AI, we can think of different steps of the design process, from identifying like needs, and then conceptualizing maybe a physical or a geometric solution, and then producing that solution or manufacturing it. I mean, these can all be considered parts of the design process. And where does a computational or a learning-based tool get inserted into each of these, or into all of them, horizontally integrated, and then extended throughout the life cycle of the product? That's all interesting, I guess, like domains to talk about. So yeah, so if you think of, if there's the domains of the product life cycle, and then there's different types of computational aids that can be, or learning based AI, machine learning based.
So let's limit the conversation maybe to machine learning, to be able, because as you mentioned, AI is a bit of a term, especially nowadays, is very easily thrown around by almost anyone.
Yeah.
Who just uses a slightly smart algorithm, but learning based as foundational models. How can they be used, generally speaking, at least in different stages of design?
Yeah. Well, the most research that I have done has generally focused on the functional stage, kind of identifying needs and mapping these to solutions, but then also thinking about ways that they can be embodied and produced. And in this case, when you're introducing a tool to it, like a computational tool, you want to look at, and gets a bit meta, because then you're thinking of designing something for a designer, right? What would the designer benefit the most from? And we think of like, what qualifies or characterizes a good designer? Usually you think of someone, in this case, who has lots of experience and has developed that intuition to be able to understand what kinds of problems are important, and then identify good solutions to those. So then if you have to kind of break down this intangible definition of intuition. I mean, what makes this intuition? And I mean, you can say it's an understanding of just experience, having lots of examples of prior designs that have done well or done poorly, and understood when choices went good or bad. So somehow, if that experience can be captured computationally and then given to a junior designer, someone who's just starting out in their career, that could be a huge win for the design community, because then those designers could be able to access and not have to spend their whole career catching up on developing that intuition, but then really start quickly to tackle problems that are pressing, climate change, for example, developing these types of complex solutions. So how do you capture knowledge and deliver it in a way that will give someone intuition a lot quicker. That's one way of thinking
And
about it.
it's a bit of a balancing act, I think, to some degree. Probably the most legendary programmer, John McCormack, has these stories of coding games basically in assembly and Doom, I think it was in C. And many see that like the 1990s as like the peak of programming. But right now, I think with AI being introduced in many branches, you might have this, as we mentioned, like the playing room that every developer has and every designer will have when we have now introduced this term that you work with virtual design assistants as AIs. Do you think that it's something that should be strived to keep that type of learning curve that every designer goes through, or we have to introduce a new way of thinking, basically, of the design process and training designers, junior designers, as you mentioned? So, yeah.
I mean, that's the question when you introduce any type of tool, right? Is what do you miss out on when you're not learning that? For example, some of the tools that I develop help to retrieve information from long-form documents. And from one perspective, that really saves time, right? Because you don't have to read through lots of documents. But on the other hand, you can think of the pedagogical process of going through lots of documents. You probably see stuff that you don't need to know in the moment, but that's a learning experience in itself. And then with design too, I mean, they always say a lot that you learn from failures quite a bit. You know, if you kind of eliminate all the failing steps, how can you is there a way to still replicate that, but then keep transferring knowledge from some previous source? So it's a good question. It has to be done, I think, through a lot of human validation. So any of these tools, when they're introduced into design, have to be validated very thoroughly with people who are practicing design and seeing how this impacts their practice, really. So that is a key limitation of making shortcuts or cutting corners in this case. Yeah.
And when we talk about creating these virtual design assistants, though basically, what are the aspects through the training process that we have to take into consideration as being like the main elements, if we go and focus just on the functionality aspects?
Yeah. So with any data-driven tool like a virtual design assistant, the hardest part is to get the data, really, to then drive the decision making. And that's AI has transformed the fields that have had the most data ready for computation. And if you think of design, we really don't have those massive data sets of instances of product design that have been labeled, that have been saying this is a good design decision, this is a poor design decision. Partly because it's hard to say what is a good or bad design decision. That's what something like an axiomatic design methodology can help with providing a framework for. So a lot of the key step there is to build that or construct that type of a knowledge base that can then be used to train or inform the model on what has been better or worse type of design decision.
And as you mentioned, there are so many different design processes, all of which I think to some degree or another can be implemented in like training an AI model.
Yeah.
Do you think that's slightly a challenge in creating like more multimodal models, or can it be a positive factor?
Yeah, I mean, when you say multimodal models, yeah, I mean there's different types of data and different design principles definitely there to train on. If we think of the design that's taught in the university and then the design that's practiced in the industry, they're a lot different, right? And oftentimes each company has their own sort of standard operating procedure, their handbook of dealing with problem solving. So then the question is, if you have all these different approaches, but then you have just one method of training or informing designers, how do you then transfer that knowledge to all these different types of settings? So, and then also if the data, like you said, multimodal data, if you're dealing with textual or image or all sorts of different data forms, that's another challenge for sure. Yeah.
And as you mentioned, all of these companies, especially the bigger companies, have their own design philosophies and inbuilt apps specifically for design. I think I read a Bloomberg article that had noted that many of the unicorns that have popped up in the US in the past 5 years have been basically design process companies of people that left one of the big companies and just implemented that design process as an app for everyone.
Yeah, yeah.
Do you think that that's kind of creates a constraint for creating better design models for AI, that everyone has basically their own data and it's a bit locked up there?
Yeah, no, that's a huge constraint. Definitely. Because when we're working in the academic settings, it's often lots of open source data sets that we can work with. And then when you get to industry, intellectual property is so, I mean, that's the core value of most businesses, and that's not something they're willing to give up. You have to then think of it as a negotiation or some sort of a fair trade. If they're going to provide or share their design knowledge with some model, what are they going to get back in return, for example? And I mean, from that perspective, you need to think of larger motivating questions, like maybe something like, especially in Sweden, something like sustainability or climate change, something that maybe a set of companies can all agree is something that they must work towards, and they need to work towards it together. And then in that case, can they share enough knowledge with each other to help still preserve competition and preserve their intellectual property, but then still be able to solve this or make better products, design better products from a sustainability perspective than they would have without the knowledge. And then sustainability may not be enough. Can they design better, more high-performing, more lucrative products also by sharing this knowledge together? So you have to think of where do they benefit from in order to present that as a fair trade.
But I mean, how would you encourage, basically, if we say we have three different companies, to share the data with one another? I mean, and especially like if they have a collaboration system so that they work together, they might even create one model together, but still use it only for themselves. Do you think like about like open sourcing data to everyone, or?
Yeah, I mean that you can think of. I mean that may be a bit. That's maybe a bit of a leap, thinking of open sourcing all, or corporate or industrial data. But think of right now you have different types of corporate partnerships that engage in data sharing. One is where you have these supply chains, right, where something like a General Electric produces airplane engines for Boeing, for example. I mean, there's a lot of knowledge sharing between these two, and they're symbiotic in that sense, but not necessarily between Boeing and Airbus, for example. Then you can think of other cases where there's companies that maybe are in completely different domains also, that sharing knowledge wouldn't really affect them because they're not competitors in any direct or indirect way. But then I guess the hardest part would be if you do have like an industry like the airline industry and you want them, Boeing, Airbus, Bombardier or whatever, that's a pretty small industry in terms of the number of big players there, but I guess for commercial aviation. But if you want them to all share data, that's probably the biggest challenge then, because they're all in direct competition. And then you need to present it in a way, because it's the business world, that then they would gain more than they would without sharing the data. And I think it comes down to being able to produce better products. In this case, I mean, if we're talking about commercial aviation, they're going to have to be more sustainable, right? And so that's a tall order. I mean, that's like a big.
Well, the doors
challenge.
have to not fall off as well.
Sure,
Just
I mean,
if we make it have a Boeing joke.
Yeah, exactly, right? I mean, you can point to maybe cases where some companies are maybe more invested in reestablishing their image as a well-designed or a company with a good design practice, like Boeing, which has had some stumbles recently. So yeah, it's a tall order.
So let's talk a bit about sustainability. I mean, it's always hard to, especially in context of generative models, introduce a certain specific topic into the model from the outside without kind of messing up its weights and biases. How could we implement? Oh, well, it doesn't necessarily have to be a generative model that we're talking about, but in general, in learning systems, introduced the concepts of sustainability to be a general overgripping factor in
Yeah.
the design process.
Yeah. I mean, that's a good point because whenever you talk about, AI for engineering design, one of the key goals then, as we said, is to sort of capture prior knowledge and examples and use that to guide designers. Then the biggest question then is, well, we come from a arguably unsustainable history of industrial design. Is this what we want? Do we want to train on this type of industrialization then to inform what? Just more the next steam engine, right? That'll catalyze the next industrial revolution built on fossil fuels. I mean, that's not a great pitch, right? So it's kind of maybe hard to make the connection between a learning-based model and overarching themes of sustainability. But if we go a bit deeper, and this is, again, we can think of sort of structured design representations at the highest level. Doesn't need to be maybe motivated, but if you think of very detailed design decision making, what in the past has been types of sustainable design, and how can those be used to influence design decisions now? And it doesn't have to be an overarching theme. It can be very detailed, and that's probably even better if it's kind of like a day-to-day type of decision making that can guide more responsible use of energy or materials, for example. Designing parts that can be made from suppliers in a closer geographic radius, for example, like this, or suppliers that have better, more sustainable or more societally low impact supply chains. So I think it's hard to think about at the high overarching sustainability level, but when you get into the detailed decision making, I think there's lots of opportunities there.
Yeah, I mean, I just, as you mentioned, because the same problem in many ways, I think now I can at least personally relate it to the question of sexual biases in AI models.
Sure.
That basically, like in hiring systems, they prefer men much more. And
Yeah.
now I thought about, we mentioned designing the steam engine.
Yeah.
So it might even start thinking that coal is the best power resource for most use cases. So
Well, what's the best material, for example, for designing something that's going to be like structurally load bearing? I mean, it's probably some sort of steel. It depends on the use case, right?
Yeah.
Right, that sort of intuition that's baked into us. I mean, steel is hardly a low. I mean, you can ask H2 Green Steel here in Sweden. There's maybe sustainable ways of producing steel, but our sort of go-to based on experience is not necessarily a sustainable decision. And that's just the experience. That's like the data-driven mode of thinking in design. So yeah, so how do you think outside the box? There's a type of learning model, right? Generative adversarial networks, a way of, presenting a decision and then trying to combat it and saying, okay, well, if this is the decision, how can we think of a different, or how is it wrong? How can we explore or exploit loopholes, in this? So let's say that my model always says steel as the go-to. Well, then can we learn of a better way to do that? Interesting topics there.
Yeah, I mean, it could potentially like implement a cost function in it for like carbon taxing or something like that to have as a reminder. Do you think more companies could start implementing and sustainability as an overarching factor in the design process, generally speaking, in the near future? Well, better to say, will it become easier for them if AI models are available that could have that as an in-baked factor in them?
I don't think that AI is the limiting factor, or that capability is limiting factor for baking sustainability into design decisions. When you think of, just how the market works and how businesses derive profits, they're just driven by how they can economically be successful. So indirectly, then you have to think of how can the sustainability be the most economical way forward, and that's getting a bit outside my expertise. But I don't think that like access to AI is limiting sustainability in these types of industries.
Yeah, I mean, I always try to be very cautious because I think there are a lot of people that like to use AI as like a silver bullet
Mm,
for saving the planet in terms of like climate change,
yeah.
but in many cases it's not really the AI part that is the problem, but the
Yeah.
implementation part. But
Well, one problem like climate change is that's so complex is not going to be solved by a simple solution, right? So I mean, anyone who's serious about tackling all the and climate change, of course, is just an integral part of right. We're next to um, the Stockholm Resiliency Center, right? They have this framework for analyzing the different parts of the boundaries of the Earth's or the planet. They call it planetary boundaries, where climate change is one of them, but we're exceeding sort of the Earth's capacity on so many others. And so you can play with the different knobs and try to adjust one impact of human activity, but then you might affect another one. So it's always harmful, I think, to think of a technology as a sort of silver bullet solution in that case.
it's a bit of a big tangent, but I still, because now that we have started talking about climate change, but
Mm.
I'm interested to know what are your thoughts on the best implementations that the available technologies that we have in AI are for
Mm.
improving or at least trying to better analyze climate change.
Yeah. Better analyzing climate change. I mean, from some perspectives, climate change is pretty scientifically well understood. It's more like, what are we going to do about it now that we have this understanding of how the human activity has raised the temperature of the Earth and has resulted in the extinction of lots of different species, for one, the inhabitability of areas of the world, extreme weather events, and air pollution, and many other things, to say the least. So it's not as much like, is there climate change, as much as what will we do about it. And from an AI perspective, I mean, I can speak to my own experience in design and manufacturing. That's one of, I mean, if you think of design as the design of products, then that contributes to a huge slice of emissions that contribute to climate change. So is there a way that we can design products in a way that reduces the emissions that is required to produce them, use them, and so on? One example is this concept of like industrial symbiosis or circular manufacturing. You know, if we have one manufacturing process, can we not consider it as just a single linear cycle, but a process that inhabits a space with others, where they all have a key product, but then also numerous byproducts from their production? And can we kind of match the inputs and outputs of different processes together? And that's, I think, an opportunity for AI to take something as complex as a set of multiple different manufacturing systems with many different material properties and energy consumptions, and then be able to guide a human to say, if we have all of these different production systems, and we can talk about examples of these, which are cool to think about, how can they be connected in an optimal way to reduce the overall material use, for example? So I think that's one direction that AI could help
Yeah,
with concrete
we
decisions.
could we describe it as basically finding new alignments?
Yeah, interlinkages, yeah, synergies or symbiotic relationships. We can think of it in the design perspective as like functional relationships. So if there's one product that has a certain function that needs to be satisfied, then we need a certain solution to embody that function, for example. Can the physical embodiment then be derived from a byproduct of a different manufacturing system? That's one way of thinking about it, yeah.
I kind of now we
Mm-hmm.
can tie it back into the main conversation about design. And can companies start using AI models to detect where they need to improve their design? Basically, AI for AI or something
Yeah.
like that.
Yeah, yeah. If we're talking about AI being used to improve design, yeah, that's definitely something that a lot of companies should be focusing on, and they are. And then, yeah, if you're thinking about the early stage design process, we can think of where a design process is not considering certain stakeholders in the design of the tool. probably not the users, because that's usually what are considered, but maybe other people in society, for example, or the environment. How can we bring in those needs and requirements into the design process? That's one way that, from a sustainability perspective, AI could be used to improve that.
And kind of bringing that back to open sourcing these models, do you think that's, I mean, I would say the Jan LeCun camp of AI people always argue that open sourcing allows smaller companies to have access to many tools that AI provides them. If we have companies that have access to their own data, they work together, the companies that already have established themselves. Do you think that makes the entry point to a sector to become harder because they can keep optimizing their own workflows and design processes? Because at the moment, I think the startup world has been a bit vibrant because the old establishment companies have been very poor in improving themselves. But maybe AI can open up a path for them to be able to better work for the design processes.
Yeah,
it's a long question. Sorry about that.
No, that's a very interesting topic that you've introduced. So I mean, from a academic perspective, there's no such thing but open source. You know, when we think about how knowledge is created and shared, I mean, that's how we develop. AI, I feel, used to be more in the academic realm, maybe until about like 10 or 15 years ago. All the greatest advances were made at a lot of institutions like, you know, Carnegie Mellon, Dartmouth, Stanford, a lot of language processing there, University of Cambridge. I mean, I don't want to miss out on any of them, because universities were where it was, I mean, it has always been a lot of the early stage knowledge creation. And then, I mean, you mentioned Jan LeCun, right? Professor at
NYU at the moment.
Okay, sure, but Canada first, I think.
Yeah.
Yeah, right? Before, and then to Facebook, right?
Meta, but
sure, yeah, right. So I mean, you see, and then let's talk about Jeffrey Hinton, maybe.
Yeah, exactly.
You know,
who left Google recently, but exactly.
But before Google, Toronto, right? University of Toronto. So a lot of these like leaders in this then were poached into the tech world, which is could not be more different in terms of knowledge creation. We're talking about intellectual property also. I mean, there you create something, and sure, you open source maybe parts of it that you want startups to use, but for the most part, you keep it under lock and key, and the peer review process is completely different there, right? I mean, here in academia, we publish some result, and this is idealized, of course, because it's not perfect in academia either. But then you offer that up to the community, then for it to be hacked away and pieced apart, so that really you can find every single problem and everything that's wrong with it, and everyone writes their own papers on why you're doing the wrong thing or the right thing, and then they build upon that. And in tech, that's just not the case, because intellectual property, you want to keep that locked up more. So then instead of creating these open source methods or algorithms, then you are creating these models that you kind of let out for people to use, and you watch how they use them. And then you end up basically with you end up with these products, right? Instead of these like new ideas, you could say. And then, they result in all sorts of different problems. I mean, I think you were mentioning like the gender-based discrimination for hiring for AI tools. And also translation also has been one of those. You think if these have been developed in maybe more university settings by, a more theoretically diverse range of people than those who are working at the tech companies, would some of these vulnerabilities be identified and prioritized a lot more than they were in the tech, where it's profit-driven and not sort of knowledge creation-driven. So I think that shift from AI being a research topic in academia to the tech world's kind of AI race, that then has changed how you think about, is it good to have these things open sourced? Because now when you have open sourced models from these types of companies, and anyone can use them, and when you say anyone, you mean anyone. I mean, there's been instances of, I mean, from across the world, sort of regimes using these open source products and using AI to do all sorts of interesting and societally negative things with them. So yeah, so then you say, okay, maybe not open source isn't the best if it's just like a very high performing but not very well validated, not peer reviewed method from the tech world.
I think that's at the moment the most controversial, basically, discussion that is going on in AI. For those who follow Jan and Geoffrey on X, it's constantly basically people arguing with each other about how much open source access people should have. But basically that has been the Meta's argument, that we open source our Llama models so that small companies start using them. And I think that I currently am personally working with AI and democracy in terms of large language models mostly and diffusion models. But just for like design, I think that if there are at least pre-trained models available that no small startup would have access to, like $100 million to put into buying GPUs. Don't you think that at least could allow many more companies to go through a very important development curve much faster in terms of like fine-tuning their design process?
It could be. I can from the sustainability part of the brain, you can ask, like, why do you want more companies working on this?
Well, from another perspective, I mean, people would say we have like everything is becoming much more consolidated in terms of like not necessarily just AI companies, but generally companies are becoming fewer and more limited in terms of the scope. So
I see,
we have right now just I recently read, actually, interestingly enough, on the airline industry, is that no other company can even compete on costs when it comes to Airbus and Boeing.
Yeah.
Because they have their establishment, they have developed them through almost 100 years now to where they are now. And no one else can has the funding to be able to compete with them.
Yeah.
Despite the fact that we see, I think Boeing has had issues with the 737 airplanes for many years now.
Yeah.
So it's interesting always, and you have like people like Elon who suddenly come up with a very much more efficient design process through Tesla. So that's basically, I would say, as one side of the argument.
Yeah, I think it's a good. It's a good point. So then, since you answered my question, I'll answer yours. So then, why should we not open source more of this types of pre-trained design models, for example, and allow more design-oriented engineering AI startups to proliferate? I think that it depends on the knowledge that these like enterprises would bring into using these products. So are they just using them as black boxes with just putting in their inputs and getting their outputs, like most startups are these days, just calling an API and performing a task without understanding how the biases of the training affect the outputs? Then if that's the case, then, and I still think that it's not great just to have these types of models proliferate, because what you're doing is you're proliferating all the bias without understanding its effects. And yeah, we can go into examples of that, but I think that there is a lack of validation in societal and environmental effects of all of these models, because they're coming from not a place of peer review, but a arms race, as the Google puts it, in terms of rapidly achieving quick progress without doing proper validation.
Are you worried personally about what are your thoughts on Max Tegmark's basically Moloch argument that this arms race is going to be a bit dangerous in terms of, well, his argument is mostly AGI, but I think like in terms of sustainability, definitely the impacts these huge training models have are quite big. So yeah.
Yeah, and there's there's different timelines to these arguments. I mean, if you go all the way to, there's some who are afraid of, I mean, we've been afraid of AI taking over for quite a long time, right? Isn't that War of the Worlds, right? So that's from a long time ago. Already we have drones that are equipped with weapons and image recognition systems. Okay, so AI is killing people, you could say, right? Already, and not just killing by indirect causes. It's pretty serious. Until that happens, where there's some sort of like an algorithm that's kind of understood that its reward function is to eliminate humans. I think I'm not personally afraid of that in the next few years. Already, though, people, and generally not people like myself who live in a highly developed country, and who have my demographic characteristics, they're not experiencing these negative effects right now and have already been. But in the U.S., at least, I mean, which is usually a great example of how things can go wrong sometimes in terms of technology. AI has been used to determine, for example, the likelihood to which someone will reoffend in after they've been convicted of a crime, and then that is used then to determine their sentence length. And they use training features that then predispose minorities, specifically Black Americans, to be sentenced for longer then. So, I mean, that does worry me because it's happened and it's been investigated, and they've stopped doing that. But then what other things then have AI been sneaking in to make the decision-making easier? So it does worry me. But again, it's like with anything, how far is something from your own personal experience that it starts to make you really worry? And I think that's what we have to try to do as a scientific community, is present to people how this is really affecting people closely and in a way that's not too far in the future. Like, there's concrete issues that have to be addressed before World of Worlds.
Yeah, exactly.
We don't have to wait for that.
No, it's interesting because I think at the very same time, it's a bit of because of the public's perception of the T-800, I think was it, or something, from Terminator 2, of AI at least, and the realities of the current systems, which are basically just churning data and learn through that, is that there is a societal worry that is quite unjustified, but also there are many societal worries that are non-existent, and there should, more people, I think, should be a bit more worried about them. But I mean, there's always need for a broader discussion regarding these issues. But how much oversight do you think that, I mean, going back maybe slightly to design processes, how much oversight do you think humans should have over these AI decision makers? Or better to say, you work with decision assistants.
Yeah.
So how much should the assistants be, and how much should they have unsupervised control?
Yeah, and that question we kind of sometimes frame in at least in engineering design, in this concept of hybrid intelligence, where look at what humans are good at doing, look at what the computers are good at doing, and then see how you can maximize the effectiveness by putting them together in an elegant way that doesn't inhibit each of them from their functions. So computers is obvious, right? Huge memory, very rapid computational power, able to make decisions like that. Humans, very creative. And what parts then of the design process can you decouple the sort of time-consuming, high-costly effort from the creative parts? If you're talking about early-stage design, you can think of, and there's many different examples. If you think of even like policy design, for example, policy research. Here we have Stockholm Environment Institute, SEI, is pretty close to here. They do lots of valuable tasks. One of them is to take policies and assess how these policies, for example, of an urban sanitation system, how they align with mitigation and adaptation for climate change, how these requirements. And what they do then is they have an expert with a PhD, several experts with PhDs, go through hundreds of pages of documents and then try to find evidence of this research question that proves it's in synergy or a trade-off with this research question. And that takes so many experts' time. Can you then insert some sort of a design-informed model, probably a language model in this case, that can pull you those evidences and make those functional connections from a design perspective? So then the researcher then can just really look at the big picture and kind of from their experience identify, based on the evidence extracted from the model, what is the pattern that they're seeing. So that's one example of how you can bring the computational tool together with the creativity of the human. And I think that's the kind of balance you have to achieve.
And in terms of the biases that might exist in the data, I mean, we had discussed it slightly, but do you think that if we do manage to make AI models that are, because there's always the question of human bias as well.
Yeah.
So how can we kind of, in your opinion at least, balance these to have a situation where we improve ourselves in terms of our inherent biases that might exist in us, and also have oversight over the biases that might exist in AI?
Yeah. That's the key, right? I mean, the AI is biased. We're biased also. What is the ground truth then if you have a question and you have some sort of evidence? Sometimes you can take the model, and if you're assuming it's biased, you can take that answer and then say, why is it biased, and try to dissect that and then train upon itself in that way to try to eliminate these types of biases. And humans, I mean, we're also informed by our training data, our experiences as well. And yeah, because there is no source of really ground truth there's an obvious way, except for kind of learning from each other and being very intentional when you make decisions to validate and say, okay, but where are some sorts of biases that may have played into the role of decision making if a third party comes through, if a peer reviews it. This is the part that's missing again in the tech world, but we still have in the academia, where you can present this decision making, have someone else review it, and then be allowed to say, okay, no, you get to retract this or work on this and revise it because that's not meeting the sort of bias validation that is some sort of standard. So there has to be the community involved to validate.
Yeah, I think it's to some degree goes again back to the question of openness. But yeah, it's just at the end of the day, I think most questions end up with trying to manage a balancing act of these different factors that everyone has to take considerations to. But now, maybe trying to close the discussion about AI to move into maybe more fun things. I just want to wonder, what your personal thoughts are in the both short term, that is to say, 1 to 3 years, about both the potential positive and negative impacts of AI, and also slightly more long term, say 10 years.
Yeah, I mean that's what we were talking about, these timelines of when does it, you can think of yourself as selfishly, when will this affect me in a bad way, and then work back from there. If you are, in some sort of a position in a developed country with lots of resources, you're going to be in kind of the user demographic that these AI companies are trying to make life better for. So in that sense, selfishly, it's going to get really good for people at a university, for example. In some ways it'll get worse because we're a society. So if it gets better for you and worse for others, that really doesn't make it better for you, because you're part of a group here, like a human group. And so then you can say so short term, to answer the question, short term drawbacks are this data driven bias, basically using sort of unvalidated data then to make serious decisions that impact people's lives, like something as simple as translating pronouns into very gender stereotype roles, for example, in Google Translate, or informing hiring or sentencing. These are the short term or post or prior term negatives that have already happened. And then in the long term, yeah, it's in the long term, I think it's kind of a loss of thoughtfulness and decision making because when you think of so we have students here that are using ChatGPT to write thesis proposals, theses even, essays. Again, like the designer who's cutting the corners, what do you lose when you cut the corners of trying to make a well-structured argument and put that into a 2-page essay and you just give a few bullet points? I mean, that takes some, excuse me, that takes a bit of thoughtfulness to architect a point and provide evidence for that. If we all lose that as a society and we just think in bullet points, that's a big thing to lose, I think. And that could be a long-term consequence of these generative language models being used just willy-nilly, widespread and very informally.
So we began our discussion slightly on the topic of the junior designer. Do you think in 10 years' time, still people will be looking for junior designers or not? And I say that recently PwC, I think, published a report that said that both Google and Amazon had started cutting the staff in different parts of their organizations and replacing them basically with Gen AI models. Yeah. So it's already started to some degree, but
I mean, that plays into the question of when a new technology comes, which jobs get axed, and then, of course, which jobs are created. So instead of someone who will take notes at a meeting, you'll have, a prompt engineer, these types of new roles. So yeah, I think, and that then you have the economic repercussions, again, out of my wheelhouse, but for example, automation in industry, what kind of artisanal jobs that eliminated, you can probably apply that to this as well. So instead of junior policy researchers that just kind of comb through lots of pages of documentation, you're going to have a different type of role emerge for sure.
Just on a endpoint on that, perhaps, I read recently a paper that Maynard Keynes had published, I think in the 1920s,
the
about
famous economist.
Yeah.
Okay.
And this was a less famous paper, but it was very interesting for me because he had basically predicted that a majority of jobs will vanish by the year 2030.
Jobs in general.
Yeah.
We're coming up on that.
Exactly. And we are at a precipice. It's that many do argue that perhaps at least very many jobs will be vanishing to some degree or another. And of course, new jobs will be created. But what those jobs are the subject of argument. But
also think about the world and kind of outside maybe our bubble. And if you've traveled or have family in different places in the world, think of the degree to which technology is used or not used in these places. And, we can still think, I mean, what are we, 2024 now? So in 6 years, are we not going to have any jobs? I mean, no way. When do we reach that point, when society is completely automated and we don't have any need to work, I guess, at least physically, that's interesting to think about. But I think that we have so many complex challenges, and you also have to think of the increase of technological capabilities with also the harsher environments that climate change is creating. Are we going to reach there before the world is such a place where we have all these new types of challenges? I don't think so. I don't think we'll have all jobs eliminated before then.
Yeah, so Maynard was not entirely right about that in the 1920s.
Who knows?
Yeah, I mean,
hard for us to make predictions about,
exactly.
about in 100 years in the future, so I won't hold them too much.
Yeah. But you brought up a subject that I think is maybe we should take a look into it as well. Sustainability in terms of the discrepancies that exist between different countries. I mean, as you mentioned, we are in a very developed country, and yet even in Sweden and Europe, the state-of-the-art AI, except for maybe France and Germany, especially a few companies in France, isn't in any way on par with the state-of-the-art in the US. Do you think
or
that...
China.
Oh, exactly, China. Do you think that that discrepancy is something that can be improved upon through AI, or is it going to get worse?
Yeah, and I mean, that's a question that Europe is asking itself right now as the regulator, known to be the regulator. How do you regulate something if you're not the leader in it? For example, that's a good question to ask. There's also the question of, do you want to be, again, like, do we need more innovation in AI? Like, where is it enough? And I think it comes down to, like, what are we lacking? And comes down to the validations and such, those biases. But catching up with the US is difficult in terms of innovation. But also catching up with Europe in terms of sort of human welfare is also hard. So you can have these you can think of these two different societies and where they differ. One maybe a lot more innovation, industrial, corporation focused, and the other arguably, I mean, there's different countries, of course, but has a lot more emphasis on the well-being of people, you could say. And so that just makes it hard to say, how do you like transform one, and do you even want to transform Europe into a place where something like Silicon Valley is very widespread, where you're working 60, 70, 80-hour weeks, everyone, and making lots of money, and you don't have any time to spend it, and you don't have healthcare, unless you are one of those richer people. So it's an interesting like trade-off. What do you have to give up in order to be such a innovative leader? But I mean, I think Sweden is an example where you can be very innovative and still have a very strong sort of social welfare system. I mean, Stockholm is a very sort of, it's a great place to be in the startup scene. Maybe not like Silicon Valley, but there's way to achieve balance, I think, in between those two.
But I take it that you're not an effective accelerationist. Or
that accelerationism, is that where you want to speed up? My understanding is that where you want to speed up sort of technological advances and then sort of bring down the society and then sort of
something
not have
on those
left.
lines. It's as far as I know, it's just a meme account on X, but
Okay.
yeah, it's growing a bit faster than I had anticipated. Some people call it a bit of a cult, to be perfectly honest, because it's such a deep belief that technology is basically the solution to every problem.
Yeah.
And
I understood it as the belief that, I mean, if we think of absolute sustainability, it would be more sustainable not to have human civilization, right? And they say, okay, if there's like 10 years, maybe no human activity, the Earth would heal itself from where we are right now. I mean, that's kind of interesting to think about. Even with COVID, we had a significant drop in emissions, right? Just kind of ceasing a lot of industries. So then I thought that acceleration was this idea of, can we just kind of get there a little quicker to reduce humanity to 1/10 of its size and kind of go back to a Stone Age situation where we're living in
that's one sort of acceleration.
Lifetimes, but in symbiotic relationship with the ecosystem, which is interesting to think about. The other converse is also interesting to think about. Like, do we need to live to 200 years old? All this industry into making life better and longer. Do we need that? Do we need to live to 500 years old, for example? Do we have enough? And if we look backwards or forwards in time, we can have different opinions. 1800s lifestyle probably wasn't enough, from our perspective. But then from a different perspective, it was more than enough. So, what is enough with respect to the planet's health? That's the balance, right? Of sustainability, I guess.
Yeah, I've actually had a few interesting conversations on that. And this is quite a large tangent because we are it's going to social psychology slightly, and we are both engineers. But nonetheless, we must.
But that's where university is for, right?
Yeah, exactly. But about the non-alignment of internal human psychology and basically sustainability. Because as I enjoy always my dog never being ever happy with how much food she's received, so she always likes eating more and more.
Yeah.
And that's just basically a psychological trait. You just keep giving her meat and she'll eat more.
Yeah, I think for humans too, right?
Exactly. We
Say
just
protein feeding. Okay, we might not get this for another 10 days, says our 1,000-year-old.
Exactly, and but we have kind of evolved into having this delayed gratification to being about buying more houses and living more and going to more trips. So
Yeah.
it would be interesting to see where we go because
Yeah.
we have so many tools under our hands now
Yeah. Yeah.
to do great things.
Yeah. I mean, that's the question of how, like, what do you need to be happy as yourself in your current location, in your current society? How much do you need to be happy? And I mean, that also points to like not everyone has the same requirements. I mean, for us in Stockholm at least, we don't really need to own an automobile in order to get around. But someone maybe in rural Canada might need that, in order to achieve the same level of happiness, and that comes with a different carbon cost. So I mean that's kind of the difference between equality or equity, right? How to meet everyone's needs, and then we can look at the slice of the population that's well exceeding and above, which you could argue points still to many people here in Sweden, despite the sustainable lifestyle that they lead compared to then other places in the rich in places like the United States. So it's an interesting question for sure.
We'll just have to wait and see
Yeah.
where the answers take us. But perhaps to a completely different subject, MEMS,
Sure, yeah.
microelectronic mechanical
Let's zoom in.
system oscillators. Could you give a slight insight perhaps to what they are first
Yeah.
and why they are better than crystal oscillators? And
Okay.
No, but we begin with a slight insight just to
So MEMS, microelectromechanical systems. It's a very broad term again. That's how we deal in academia, in research. MEMS, it's really like micro scale systems, and that can be maybe even to include nanoscale systems now, getting into like quantum technology, which is also very interesting. But my research is and has been kind of design driven. So MEMS is not really a problem, but a solution. You could say. The problem I was working on was how to harvest energy in a very remote environment. So where you don't really want to rely on a battery power, for example, and how could you then create ambient sources of energy into some usable electric power for a sensor, for example, and focusing then on vibrational energy as opposed to like solar energy, for example. In this case, it was a MEMS oscillator, so a way of converting vibrations from maybe fluid through a pipe or traffic flow on a highway into some sort of a mechanical deformation in a piezoelectric material that would then result in an electric charge that could be used to charge a capacitor or power some sort of a device. And there's numerous challenges associated with that, but that was my master's project that I worked on. Yeah.
But I find it, I highly recommend anyone listening to this podcast to go and read those papers. But isn't it something to think about to extract as much energy as possible through all possible means? Because I think at least human beings generally always have an interest in decreasing waste, and there is the potentials of MEMS, I think, at least from a novice perspective, is that extracting far more energy than we already are from just simple movements. So in
like human movements.
Yeah, human movements, but in many instances that energy could be extracted on a better scale than it is being at the moment.
Yeah, for sure. And when you think of concepts like just ambient vibrations, I mean that is a great source of energy. It's small though, and it's hard to kind of scale how you harvest that. But if you have very low power needs, then you can match those. But energy is conserved always, also, right? And so if you mention like wearables, and you think of a device, for example, I also worked on an energy harvesting shoe. And so that's an example where you do
also a very great paper. I highly recommend. So yeah,
that's an instance where you can. I mean, that's a huge amount of energy relatively that you're imparting when you put your whole body weight down inside your shoe. You can, in our design, you can harvest that by converting it to airflow and having some sort of like a rubber bladder or air or lung, you could say compressing and decompressing and driving a turbine, and then, there you have the electricity. But that's also gives you, if you take too much of that, that gives you a sensation of like walking through sand, because you're just charging a battery then when you walk instead of, while you get somewhere, and that can just tire you out. So then do you want sort of something electronic charged, or do you want, to be able to walk normally? So that's again a trade-off, because of that conservation of energy. But yeah, lots of different sources that you can draw from for energy.
And we had a bit of a space talk as well. Do you think like they could be applied in both microsatellites and generally in like space? Energy efficiency is always a top priority.
That's interesting. Microsatellites, I haven't thought about that. But yeah, I mean, in space, I think a lot of those systems are solar powered. But you can think of where you could harvest from other sources of energy. And space is, I mean, you get really constricted in terms of what's energetically going on out there apart from solar. But yeah, if there are some vibrations that you could somehow pick up on. Of course, if you're talking about human machinery that's launched up into space, you have motors that are running or something. I mean, those produce vibrations. That could be a source, of energy that you could. So when we say remote environments, yeah, we could extend that definitely to space.
And why should we use MEMS instead of crystal oscillators? And
I don't know. That's a competition.
I read actually like a paper on it. Was basically the title was MEMS versus crystal oscillators.
Okay. Yeah.
But I think it was just a meme name to get attention. It wasn't exactly like heads up battle. But
that's the design question, right? If you have a need or a requirement, you have multiple solutions. Which one is the best? And how do you define the good designed solution? And then, there you go. That's the competition or the conflict you have to resolve then through a design process. So yeah.
I think we have touched on some very interesting subjects, but I always tend to end the podcast on the question of just some personal hopes and also concerns about mostly about the future of humanity in consideration with AI, and what you think we should take into consideration as being like the most hopeful factors and also the most concerning factors.
I think it's easy to think about the concerning ones, and we've touched on some of them. I think it's any case where a computational model, an AI, is used then to guide a decision that negatively impacts someone's life or negatively impacts the environment. And probably in those cases where it impacts it even to a more negative extent than it would have if you hadn't introduced that tool. So that's just pretty much a loss right there. And in terms of hopeful things, I mean, we can also think of how technologies have helped people's well-being be increased by so much in a lot of different situations. And AI has a way of helping to resolve very complex issues by, like we said, taking care of the heavy loading when it comes to dealing with massive amounts of information and retrieving, manipulating, and storing that types of information. So in the context of sustainability and these complex manufacturing systems, for example, I think there's a lot of promise for AI to be used to then guide humans to find the best solutions that are societally and environmentally sustainable. But it's going to require a lot of work. I think we're more far away from that than we are from these negative impacts at the moment, which is why everyone's trying to work on it.
Yeah, and with that, I think I shouldn't take more of your time so you can get back to the yeah, that's a good ending on the subject. But I really want to thank you very much, Haluk Akay, for joining this podcast.
Thank you.
And yes, thank you.
Thanks. It's been a pleasure. Thank you. Appreciate it.